One of the nice things about the PsychoPy builder is that it also allows you to write your own custom Python code to be executed by your experiment at the appropriate time. We've talked a little bit about how to use code components to access eye data that can be retrieved via the latest sample and buffer data components, but it may sometimes be useful to communicate directly with the host PC via a code component. For example, you may have a code component already in your script, and you may want to have that code component send your own custom message to the EyeLink data file when something happens. If you've already implemented that script, you may not then want to have to additionally use an EyeLink component to handle this additional custom message. Instead, it might be simpler to just add your message to the host PC directly into your code component. The EyeLink MRI demo plugin example shows how to do this type of thing. At the beginning of a block of trials, this example waits for a synchronization signal from the MRI device before proceeding with the block of trials. Since we may need the time of this signal to be logged for every trial, we can log the time of the sync signal and then write our own message in each trial to log that signal time as a trial variable. Additionally, we can send our own message to just mark the time of occurrence of the event. The code component in the wait for scanner pulse routine logs the time and sends an event marking message to the EyeLink data file when the sync signal is detected. You can call any of PyLink's functions this way, and the name of the instance of the EyeLink object that is created by the EyeLink plugin is EL_tracker. And the PyLink module contains a function called sendMessage that allows us to send a message to the EyeLink data file. Messages to the EDF can include a temporal offset, which enables Data Viewer to move the message time forward or backward in time to position the message at the actual time the event happened. Here, the event may have happened a few milliseconds in the past by the time the script gets to the message execution. So we calculate the temporal offset to be included in the message by subtracting the log time of the event from the current time, and then including that offset at the beginning of the message with a space after it. Then, at the beginning of each trial, we additionally log that original sync signal time as a trial variable by following Data Viewer's protocol for sending trial variable messages. Here, we log a variable called scan pulse time and its value, which is the log time when the sync signal was detected. This way, we'll have access to the time of the sync signal at the beginning of the block in any data reports that are created by Data Viewer. This MRI example is a simple illustration of how you can interact with the EyeLink system using direct PyLink function calls to send messages. But this same idea can be extended to any of the PyLink functions. You can find documentation of these functions in the PyLink manual that comes with the EyeLink Developers Kit that you installed as part of the EyeLink plugin installation process.